go over Chapter 5 today. Hopefully we can do this in an hour, kind of like we did it for the last class. I want to mention this to you. You may or may not be aware, there's a gentleman who used to work here. He actually worked here for about 15 years, Doug Tabbitt. And Doug ran our information security program here, and he was offered, a little over a year ago, he was offered a job at Data Dimensions to be the Chief Information Security Officer. And once they told him it was about a 50% increase in his salary, he agreed to it. All right. So the reason I'm telling you this is he contacted me and said that they are looking for some interns at Data Dimensions. If you don't know what Data Dimensions is, it's a company. It's right off of I-39 as you're going out of here and you're going towards Janesville. So as you're going north, and they digitize documents. Now, probably most of the work that they do won't exactly be real conducive to the stuff that you'd want to do for an internship. All right, notice they say it's some inventorying, imaging of documents, some installing of equipment, etc. But if you're interested, send me a copy of your resume, and I'll send it out to him. That's how he said he wanted to do it. They pay $10 an hour, and they're very, very open with their hours. All right. They have also hired about a half dozen of our programmers from the program here. All right, including Kim Howry, who graduated from here last May. All right. So again, if you're interested, just send me an email. If you're not a problem. All right. So again, I'm gonna jump into talking about, again, since we don't have the book, I am going to kind of go back and forth between possibly looking at a couple of the PowerPoints, but I don't really want to do that. So hopefully you have your book with you, and if you don't, you can maybe look on with the person next to you, because hopefully they have their book with them. If neither of you have the book with you, I don't know what to tell you. All right? But I'm on page 279. The chapter is called Loops and Files. And again, virtually everybody in this room was in the last class. I realize there are a few of you who aren't. I get that. It's not a problem. All right? But they talk in here about increment and decrement, while loop, do while loop, for loop, running totals, break and continue. These are all things that we've looked at before in the other class. So I'm going to quickly go over them with you in here also. In fact, what I can do is I can grab that same file where I just kind of hand wrote some stuff from the last class, and I'll copy it over to my desktop, and after I do that, I'll make some changes to it and then copy it back again to the other P drive. So again, this is more for those of you who were not in the previous class. There's how you do a while loop. All right, when you do a while loop, you need some kind of a loop control variable. Oftentimes you have an accumulator, as I have here. So this is going to print out, it's going to list and print out the numbers between 1 and 10. All right, ideally at least you'll be able to take a look at that, and that'll make sense to you. So the idea is it's while, then in parentheses some kind of a Boolean condition. Boolean must be true or false. If there's only one line of code, you don't need the curlies. But chances are pretty good you're going to need to use the curlies because you're going to put multiple lines in here. The advantage is, well, what if I wanted to go in and go from 1 to 1,000? Then all I have to do is change that. And that's going to print out every number between 1 and 1,000, and it's going to add all the numbers up between 1 and 1,000. All right? So ideally, again, we'll talk about it some more, but that's the first one. Then you've got a do while. And we can actually put them both on here. There's the while, right here. There's the do while. What's the difference? Well, with a do while, you make the check at the end of the loop, so it's a post test. So with a do while, you always run through the loop at least once. If I did this, if I went back up to this while loop and I said while the loop control variable is less than or equal to -10, it's not. It would fail immediately, so you would totally skip the loop and you jump down to the line down here. All right. On the other hand, if I make that less than or equal to -10, since it doesn't check this till the bottom of the loop, it would run through it right away. It always. So if you want to make sure that you go through the body of the loop, all right, at least once, you use a do while. And I think I mentioned this the other day, but sometimes what people do is while they're testing, they use do while loops to make sure that their code is always checked. And once it's okay, then they go back and change it back to a while loop. With a while loop, no semicolon. With a do while loop, must have a semicolon. All right? So pre-test loop, meaning that you check it before you get into the body. Post-test loop, meaning you check it at the end, after you've already gone through the body at least once. The other one in there is a for loop. Another pre-test, that's a counting loop. So that does all three things in one line. So notice here we've got our initialization, our test, and changing our loop control variable. Whereas in here, there's the initialization, there's the test, there's the incrementing. So it's over three different lines. Initialization, test, and change. Three different lines. But with a for loop, sometimes people like that because it's more compact because you do everything together. All right? So what I just gave you was a short, basically an abridged version of everything that's in 5.2, 5.3, 5.4, and 5.5 in the chapter. All right? And those of you who are in this class who were not in the previous class, I believe you've all gone through at least the JavaScript class, and we talked about this stuff in there also. All right? Same looping constructs that you have in JavaScript. All right. A couple more things, in fact, even before we get to this. Okay? So if I'm writing a program and I write this, for int x equal 1, x less than or equal to 10, x plus plus. Whoops. What's that doing? It's adding 1 to x. So again, I can do it like this. I can do it like this. I can do it like this. Or I can do it like this. So those are all doing the same thing. Every one of those is adding 1 to x. If instead of adding I wanted to subtract, it's minus minus. But when you use the plus plus and you use the minus minus, it'll only allow you to add 1 or subtract or increment or decrement by 1. In other words, you can't do this. Still remember a student years ago doing this. They tried it every way. They said, I put the plus plus here, and I did a space and a plus plus. You can't do that. But if I do want to add 7 to x, then I can use that plus equals. That works. So that right there is the same thing as saying x equals x plus 7. So that is a shortcut. That you can use. All right? And there's a plus equals, there's a minus equals, there's a times equals, there's a divide equals, and there's a modulo equals for the remainder. All right? So what's the difference if there's a plus plus and there's a minus minus? Again, we looked at this in the last class, but those of you who are not in there, just so you see this. So if I come through here and I'm writing some code, let's look at these just one at a time. All right? So I've got two variables here. I've got x, which is equal to 3, y, which is equal to 0. If I do this, y equals plus plus x, that means it's pre-increment. That means add 1 to x, and then x is 4, and then assign that result to y. So y is also 4. So that line right there, and I didn't show you this last class, but that line is the same thing as saying x plus plus y equals x. But we put it on one line as opposed to on 2 lines. So if that makes more sense to you, do it in 2 lines. It's not a problem. All right, so that's the first one. What if we do this? This is the post increment. So this is the same thing right here as saying y equals x and then x plus plus. So it'll take whatever x was, which is 3, and it'll assign it to y. So that's wrong. and then it'll add 1 to x, which makes that 4. All right. So again, if it's easier for you to understand putting it in 2 lines as opposed to 1, that's okay. You may remember this. All right, I showed the other day when we talked about this. If I come through here and I'm starting to write some code, all right, let's just forget about this code that's here for just a minute. So I'm going to write some code. And I'm going to come in here and say int LCV equals, let's set it equal to 1. All right, and then we come in there and we say while LCV is less than or equal to 10. And we'll just do a system.out.println LCV equals plus LCV. All right, that'll print out LCV equal 1, LCV equals 2, LCV equals 3, etc. Then when I'm done, I can do this, plus plus LCV. Or I could say LCV plus plus, or the other ones. That makes sense? Okay. Now, what if I don't want to do that? What if I want to be able to change that, check it in one line and change it in one line? Can I do that? The answer is yes. If I set this equal to 0, now I can say while plus plus LCV, that says add 1 to it. Now I don't need this line anymore. That makes sense? So that's another way. There's all sorts of dickering around that you could do when you're working with plus plus and minus minus. That's the bottom line. All right. And again, the minus minus works the same way. So if I do this, minus minus, that's a pre-decrement. So the first thing that does is it removes 1 from x, which makes it 2. Then it assigns the value to y, which makes that 2. So again, that line that you see right there, that's the same as saying minus minus x, or x minus minus, and then y equals x. All right? So that line right here is equivalent to 2 lines right here. This is the post decrement. So when we get done, all right, we first set x equal to y, so y is going to be 3. Then we subtract 1 from x, which makes it 2. So that one right there is the same thing as saying y equals x, x minus minus, or minus minus x. All right, so it's just a bunch of wordsmithing. I'm just moving stuff around. Do it the way that makes the most sense to you. And constantly be testing too. Just to show you this, and this is something we didn't talk about in the last class, but you should all understand this well enough by now, is if I come through here and do this, people do stuff like this all the time. My intention here is to print out all the numbers between 1 and 10. Am I going to do that? No? Why not? It's going to print 0 through 9. That's what's known as an off by 1 error. People do it all the time. All right, it becomes especially important when you work with arrays, which we'll get into after the break. All right. So, looking at this in your book, what the author talked about here, I'm just quickly throwing up these slides. I'm not going to go through them in any depth of breadth of coverage at all. But, so we've already gone through the increment, decrement, the while loop. You use a while loop for input validation. We went through the do while. We went through the for loop. And I actually did show you running totals and sentinel values. So we've already went through a lot of the stuff that's in here. So if you don't have your book, you can look at this. And here they show you the plus, plus, etc. And there's a program that's in here, increment, decrement, that we could have gone through, and it shows the same stuff that I just showed you. detailed explanation between prefix and postfix, or what I call pre-increment and post-increment. The while loop, which I went over with you, mentioned that it's a pretest loop, and what goes in here is a Boolean condition, so it must break down to true or false. All right. Let's see. Yeah, you don't want to have an infinite loop. Okay, that's the way it looks in flowchart form. I still have that here or not? I had a prop, but I can't find it right now. So, all right. Again, if you're going to have multiple lines of code, it has to be in curly braces. Here's an input loop validation. Look at this. I'd like everybody to look at what's at the screen right now. All right. Why? Because in the program that you're going to do, you're going to randomly generate a number between 1 and 100, and you're supposed to check to make sure that number that you generated, after you generate it, the user is supposed to guess what the number was that you manually generated. If they guess a number that's out of range, you should do something along these lines. How you do it is going to be up to you. We've talked about try-catch. We've talked about using if statements. But that's exactly the kind of check that you're going to make. Because this says, while it's this is a range check. So again, that's saying, while that number is less than 1, which is your minimum, or it's greater than 100, which is your maximum, you have to handle it. All right? Typically, it'll be something like this, where you'll put it in a loop, or you'll do whatever. And I'll show you an example. I'll show you my running program of the one that you're assigned in just a couple minutes. All right, again, with the do while, this must be in curly braces. Even if it's just one line of code, you must use curly braces. And again, after the while, which again is a Boolean condition, that's the only time you must put a semicolon at the end. Don't put a semicolon at the end of a regular while statement or at the end of a for statement. All right. The for, again, goes through the initialization, the test, and the update all in one line. And does this make sense to people? We haven't really talked much about this, but if you look at this, what if I want to set myself up a for loop that runs infinitely? Sometimes you do want code that runs forever, 24/7. So I can do this. That literally means forever. All right. I can also do something like this. Those will both put infinite loops. Sometimes you want an infinite loop condition. You want to do that. If you've got code that's always running, and you have to constantly be checking for different things. Again, back in the days, I know I'm dating myself, but when I was working on telephony code, that's when you picked up a rotary phone and you got dial tone. All right, that kind of an idea. You always needed. That code had to be running all the time. Inside of one of those loops. Now, if you had to break out because of an exceptional condition, that's where that break came in that we're going to talk about in a minute. Okay? So they go in and explain the for loop in some detail, but we've already talked about it. And when you are doing that for loop, any one of the things, so I just showed you that for loop that looked like this. But I could set up a for loop where I have to do no initialization. So I can have, for example, this. X less than or equal to 10, X plus plus. And maybe up above someplace, I did this. Int X equal 1. Well, if I did that, there's really no sense in me coming down here and repeating X equal 1. I could do it, but why should I do it? So if I don't want to put in one or more of these, I just leave it blank. There's the infinite loop that I already mentioned to you. All right. They talk about a sentinel value in here. So let's suppose for a second that we were writing some kind of code where I was having you enter grades. All right. Then, and the grade had to be between 0 and 100. So I came in here and I said final int min score equals 0. Final int max score equals 100. And then I came in here, there's going to be some code in here, but input test score. All right. So when I come in and I'm doing this, if I say while test score less than min score, or I'll put it on 2 lines just so you can make sure you can all read it. Does that make sense to people? All right, you are guaranteeing right there that the number that you put in. So why am I showing you that? Because all you have to do basically is change yours in your program to min num, max num, and then change it instead of 0, make it 1. All right, and that's the kind of code that you're going to end up writing for your program. Something similar to that. All right, I don't care what names you use. You may not like min num, but so that's range checking. All right. Normally, if I want to say if something is outside of a range, I do it like this. So we'll call this exclusive range checking. All right. But I can also do this. And this will be inclusive. And I'll say while it's greater than or equal to this, and it's less than or equal to that. Does that make sense to people? That's making sure that whatever you put in falls within that range. So this is saying while the number is greater than or equal to 1 and less than or equal to 100, this is saying while it's out of range. So that's in range and that's out of range. All right? Why am I showing you both? Because depending on what you're trying to do in an application, you might need one or the other. But again, inclusive almost always is going to use and, exclusive almost as always is going to use or. They go through a lot of stuff in here. Gaddis does this, where he talks about style. Again, sometimes people like to put the curly brace over here. Sometimes they don't like it there. They want it on its own line. Just be consistent. I don't really care which way you do it. Do it which way makes more sense to you. That's fine. They do talk about input validation on page 290 in your book, but it's pretty much what I just went over with you. All right. There are, again, some good programs in this book. For instance, the program, and it's very similar to the one that we looked at in the C# class a little bit last hour, but on pages 304, 305, and 306, there's a program that converts from kilometers per hour to miles per hour. So if you're having some problems wrapping your head around this stuff, you might want to take a look at that program. All right. The running totals and the sentinel values. Well, what if I'm doing this? Okay, you all saw where was that? Well, wherever I just put that. I guess that's the other one. You all saw this one. Okay, what if I told you to keep entering numbers? In other words, let's just assume for a second that we got a program. I'm going to let you enter numbers until you don't want to enter numbers anymore. Okay? And what's the only requirement? Well, you got to have some unique number that when you're all done to show that you're done. Okay? Well, if this was something like this for tests, even if I had this, back where it was a min score and a max score, and it was 0 and 100, I might say something like while test score not equal to, and we'll just call this here stop. Okay, and you go, what the heck is stop? Well, what if I came in here and did this? Final int stop, and I'll set that equal to -999. That should never be valid for a test score. All right, Even if I dislike somebody, I would never dislike them that much that I give them a negative 999 on an assignment. That wouldn't really make a whole heck of a lot of sense. But that might make a, so when you pick a value that doesn't make any sense to be inputted, and you use that as a special stop value, that's known as a sentinel value. And it's from the old days, with the sentinel halt, who goes there type of an idea. What you're doing is you're trying to protect. All right. So this is a thing that can be used. So in the book, they talk about running totals on 307, and they also mention sentinel values. All right. And they allow you to keep entering stuff. There's another one with soccer points where you can enter how many points your team has earned for the season. And when you get all done, this is on 310 and 311, as soon as you put in a negative number, it stops. All right. Then on 312, they talk about nested loops. So let me get rid of this. All right. And let's talk about why we might want to do something like this. This over a bit. Oops. Now, hopefully you understand it, taking a quick look at this. What I'm doing right here is I'd be simulating a clock. In other words, my hours, I'm going to be at 0 hours, 0 minutes, 0 seconds. So this should print out 0, 0, 0. All right. Then I come in here and I add 1 to S. So now it's going to be 0, 0, 1, 0, 0, 2, 0, 0, 3. Make sense? All right. Now, I'd have to do some formatting and the like, but that's fine the way it is. So once I got to a minute, so where it was 0059, now it would be 010, and I'd go through the whole process again. And as soon as I went through 59 minutes, then it would be 100. And the point of showing you this is really easy to set up by using a set of nested loops. So I've got a for loop within a for loop within a for loop. So the whole idea of this is it counts from 0 to 59. That's its, when you look at it, that's its whole job. And it keeps doing that. And it does that while this is also going from 0 to 59. That's its sole job. And it does that while this is going between 0 and 23. And I've always said this to people, if you can understand how that works, there's no reason you can't understand anything with looping, because that's about as complex as it gets. You can literally go as many levels deep as you want to go in here. You'll typically find that most programmers don't go more than 4 or 5 levels deep. When it starts getting to where you can't wrap your head around it, all right, that usually is the time to say, maybe I ought to write this in a little bit different way. And they may even show something like this in here. I don't remember if he does or not. All right. So turning up to page 320, the next thing that's in there is he talks about break and continue. And again, many of you have seen this the other day, but I'm going to show it again anyway. That's fine. So if I come through here and I start keying in some code, you've already seen this. So if I go in while LCV is less than or equal to 10, so you've seen this code already that I'm putting in, but I'm going to make a change in a second. system.out.println LCV equals, that literally right there is going to print out LCV equals 1, LCV equals 2, LCV. Everybody's cool with that, I think. All right. But if I come in here and do this, if I come in here and say if LCV equals 7, break. So if I change it to add this code that you see in here in blue, that's now going to print out LCV equals 1, LCV equals 2 through 6. When it gets to 7, instead of printing it out, it's going to check this. That'll be true. So you break out and you go down to here. Does that make sense to everyone? And that's explained in your book where they go into the break and continue on page 320. So again, the output of this will be 1, 2, 3, 4, 5, 6. Now, not with the commas, but you get the idea. All right. So if instead of doing it like that, I'm going to just comment all these lines out. If I do the same thing, should have done that before I commented them, but that's fine. So if I do the same exact thing in here, but when I say if x equals 7, instead of putting a break statement in there, if I put in continue, all right, so in the first case, where we had the break, as already shown, it's going to print out, oops, it's going to print out 1, 2, 3, 4, 5, 6. I think I just brought the other one out. All right, in this second case, so that one right there is going to cause this to be printed. So that prints that. Okay. This one with continue, this one is going to say prints 1, 2, 3, 4, 5, 6, 8, 9, 10. So break breaks you out of whatever you're in. Continue says, oh, just skip the rest and go back up to the next iteration. And in that case, I probably would here, I would want my LCV probably put up higher, because as soon as it hits continue, I'm going to have a problem right there. All right. So again, break breaks you out of something. Continue stops the current iteration, and it goes back up to the top of the loop. All right. Then we go back to the same exact stuff that we ended the last class with, and that is if I just work my way up here, again, which loop should you use? You know, you can read whatever you want to read on this. There are people I know that do everything in the world they can to use a for loop because it's a little less code. They think it's more compact and it's easier. There's other people who will tell me, I'll use a for or I'll use a while, but for the life of me, I don't want to use a do while. All right, so you should use the ones that you have the most comfort with. All right, same kind of stuff we looked at before. File input and output. Files can be input files or output files. Binary files are ones that you can't read with a simple text editor. Text files are ones you can read. All right. So if you notice in here, now notice what we have. It says to open up a file for output, you have Print Writer, where previously we used Stream Writer. Okay. But it works the same way. What we're doing right here is we're creating a local variable called output file, so we don't have to refer to the file studentdata.txt like that. This is called giving that file a handle. So that's what we're doing right there, is we're giving it a file handle. Now notice what this says. If the file already exists, it'll be erased and replaced with a new file. And that's really important. Because if you had a file that existed that was called studentdata.txt and already existed, and it had 1 million records in it, doesn't matter. It takes that file pointer that I talked about in the last chapter and it puts it right at the beginning. Boom, as soon as you write something, it overrides what's there. Okay. This is all very similar stuff to what we looked at before. Okay, so when we go through here and we start looking at the stuff, this looks almost identical to what we looked at in the last class. except in the last class we did a console, but here it's a print line. So that's going to put Chris on a line, followed by Catherine, followed by Gene, and that'll close the file. All right. There's a file write demo. I will tell you that if you understood the program we went through the other day, all right, if you were here the other day when we went over the savings account program, the one that I did for you is much more complex than any of the ones in the book. All right, next they talk about exceptions. The good news, or bad news, depending on your point of view, is I made the semi-conscious decision to show you exceptions earlier in the semester, so you've already seen them. So the author is talking about those right here. This is all the way in your book. In fact, I don't even know where it is. But again, an exception is something that typically you don't want to have happen. All right? The key thing, the reason that the author is mentioning this here is, and we talked about this in the last class, this line right here. I want you to understand, even if you aren't super paying attention right now, if you could look up on the screen for a second, I want you to understand this. What this line means, right here, this is one line of code, even though it's put over two lines. Literally what that line means is it is possible that this method could throw an I/O exception. That's what you're doing, is you're telling the system, not that it will, but it's possible. And again, why do you typically throw an I/O exception? Because you try to read a file you don't have access to, or write to a location you don't have access to, or you try to read a file and you give it the wrong name, or you give it the wrong location or something like that. That's usually, all right? But the system, what it does is that it's sending a subliminal message, for lack of better words, to the compiler. Hey, you better watch out because it's possible there could be some kind of an input-output exception in here. And that's what you're letting it know. And I think I told you this earlier in the semester, but I'm saying it again. You'll hear it again in fall. That notice it says throws exception. You, as a programmer, can manually throw an exception without the S. When you put the S on the word throw, it means it's being done by the system. So this is saying it's possible for the system to, the system throws, you throw. Okay? And that's what they're talking about right here. Inside of the curly braces, you might, and not only that, one reason that you might want to do it is it's also possible for you to throw a different kind of exception other than this one. And it's possible that you could throw more than one kind of exception. So, for example, this could say public static void main, all the other stuff, throws I/O exception, comma, number format exception. So you can tell it that it's going to throw more than one kind of exception. So the author says here, what you can do, says to avoid erasing a file, you can create a file writer like this. And what this right there, what that true says, is only created if the file does not currently exist. All right. There are also, and they'll get into this in just a minute, there's also a method that you can use that's called, here's a hard one to believe, file exists. And you can call that to see whether or not a file currently exists. All right. Anybody know why they're doing this? Remember that backslash is an escape character? So when you put backslash, what you're saying is that's on the A drive and the name of it is pricelist.txt. If you do this and you only put in a single backslash, it thinks that what you're trying to do is a backslash capital P. Doesn't know what that means, so the program blows up. All right. If you kind of go at this with the mentality that the software is there just waiting for you to screw up so it can pounce on you, that's a good attitude to have, because that's pretty much the way most software works. All right, that's what he talks about in here. Now, as it says, Java allows you to use forward slashes in your file names. Most languages do, even when they typically expect it to be this way. They'll accept it that way. All right. So here's reading data from a file. And this is that same, very similar program to the one that we looked at in the last class. All right. right, so they're talking about it right here. Again, this is where I got the idea for the one that we did in class the other day. But again, hopefully you realize that from what we had in class the other day, and that was we had separate files, one called deposits.txt, one called withdrawals.txt. And we basically told the system to open those files up and read from them and do whatever it is it had to do. And we didn't want to worry about it. We had to set it up, and then we just told the system to take care of it. All right? Again, you can have I/O exceptions for reads and for writes. End of file, I use something like that, I believe, in the example. Literally what that does is this uses what's really referred to as a peek function, P-E-E-K, like when you're peeking around a corner. So what this does is it checks the next record. And as long as it sees that there's a record there, it'll go on. But if it checks the next record and it's come to the end, then what you have is a special thing that's known as an end of file marker. And when it sees the end of file marker, this will fail then. All right? And that's what he's talking about. Again, you should always close files when you're done. If you don't because you forgot or you just don't want to, when the program finishes, the file will be closed, but that's considered rather very poor programming practice. All right, so just like we did in the last class, and I'll have to update that one, this one also, but if you look in here, all right, everyone with the exception of maybe one or two people has done this stuff for Chapter 3. All right, so you've done the employee class and the car class. Some people have done the employee class and not the car class. A couple people haven't done anything yet. So you really should get that stuff in as soon as possible. As I said for the other class, that a week from tomorrow, I have to have midterm grades in. And I'm turning them in by the time I leave at 5 o'clock. I'm not going to be doing midterm grades on Friday. That's technically when they're due. I'm not going to do them then. All right, so if you have nothing turned in Friday by 5 o'clock, by the time I leave, you're going to get a U for the semester, for the midterm grade. Okay, so those were due already. The next two, the BMI one and the speed of sound, are due today. Just like with the last class, and I'm saying it, it's being taped, I won't grade stuff till Friday morning. So as long as you have it in by Friday morning, well, gee, Jeff, when on Friday? I hate playing that game. I mean, I had it to where I had to tell people I would accept stuff until 11:59, 59, you know, and I just don't want to play these games anymore. It'll be sometime Friday morning. When? Well, I get up in the morning and I work out, and after I work out, I come home and then, or either shower when I work out, or I shower when I get home. And it'll be then. So when is that? I don't know. It depends on when I wake up. Friday is the only day that typically I'm allowed to sleep in, period. And to me, that's 7 o'clock. All right. So the other two, again, both are being assigned today. So this is Wednesday, 02/25/2015, and the due date will be 2 weeks again from today, Wednesday, 03/11/2015, and I'm just going to copy that, and I'm going to put it here. All right. So the one is the savings account program, the one we did as a class. The other one is the guessing game, which I'm going to show you in just a minute. Now, we're really doing well. And what I mean is, when we come back from the break, I'm going to go over Chapter 6, and then you'll have a lab week. Chapter 6, 7, and then a lab week. Chapter 8, and then a lab week. And that's it. So that gives us 3 more weeks. And if you weren't here the other day, what I'm going to try to do with you, with John's help, all right, is we're going to see if we can write an Android application as a class. Just so you see, because the way that I teach the advanced Java class, and am I going to teach in full? Nobody ever tells me until the week before what the hell I'm teaching anyway. So I'm not going to guarantee that I'm teaching anything. But the way I've done it is the first 9 weeks I finish the book, and the second 9 weeks you get an introduction to Android. So you're getting an even earlier introduction to Android. All right. So when we come back from the break, you'll have programs for 6, 7, and 8. Now, just to show you real quickly the kind of thing that I'm looking for, I'll start up Eclipse again. Now I'm hoping I didn't make any mistakes in here. A student asked me about, he's already working ahead, and he's doing the rock, paper, scissors program for the C# class, which isn't until like chapter 6, and I found a mistake in one of my programs. It wasn't really a mistake, it's just that I should have taken a text box that was in there, I should have made it read only, and I didn't. Alright, so let's see. Okay, so that's it. So I have to bring that in so I can show it to you. APS job. So guess the secret random number 1 to 100, 50, too low, try again, 75, too low, try again, 88, too high, try again, 45, no, that wouldn't make much sense, would it? 80, all right. Very similar to the one that we're doing for the C# class. All right. So if you do look in your book, the actual program that you're being assigned is on page 352. It's numbers 17 and 18, the random number guessing game. Write a program that generates a random number and ask the user to guess what the number is. If it's too high, it should display too high, try again. If it's too low, it should say too low, try again. All right. And if you get it, you should also keep track of how many guesses they've made. All right. And I don't remember on mine. I'm going to show you right now if I put in any error handling or not. Nope, mine blows up when I put in something non-numeric. It'd be nice if you tried to handle non-numeric. All right. And I do believe on mine, again, we'll check right now. I wrote these last summer, so I can't tell you what it does or doesn't do. But if I put something out of range, all right, it just says too high. What you really should do on yours is you should verify that it's numeric and that the guess that you put in is within range. Okay, does that make sense? Now, how you want to handle that, so if it says, give me a guess, and Eric types Eric in there, and he comes back and it says that's non-numeric, try again. If you want to count that as a guess, fine. And if you don't want to count that as a guess, fine. I don't care how you do it. If you only want to count guesses that are between 1 and 100, you can do that. All right, I've had people go nuts with this and really put a lot of stuff in there that I wouldn't have even thought of doing. All right. So again, it'll be lab all next week. Week after that's break. So when we come back, it'll be chapter 6 lab, 7 lab, 8 lab, which will give us 3 weeks left. And at that time, again, the plan is to go through and do a fairly simple Android application with you. All right? Questions? All that I had.